Welcome to lesson 1-9, where we are going to talk about inverse functions. And let's start by just giving an informal definition of what an inverse function is. All an inverse function does is it maps the range values of a function to its domain values, which really all that means is it takes the y value and it brings it back to the x. So normally we plug x in to a function to find y. With an inverse, we're going to try to plug y in to find x. So let's actually look at our first example. We're going to informally find an inverse function. So what we're going to do is we're going to take the function f of x equals 4x and find the inverse of that. All we are going to do to find the inverse, let's rewrite the function as y equals 4x. And then we are going to switch the x and the y. So instead of it being y equals 4x, we're going to have this be x equals 4y, and we're going to solve it for y. In this case, to get y by itself, we're going to divide by 4, and we're going to find that our function, our inverse function, is going to be y equals x over 4. So we can write that as f of x, or f inverse of x, is equal to x over 4. Now, another point of finding an inverse function is if we take the composite of our function and its inverse. So if we take f of f inverse of x, we should be able to get just an x in the end. So let's try that. We know f of x is 4x. So we're going to take 4 and we're going to replace x with the inverse function we found, x over 4. So 4 times x over 4, well, these 4's, they're going to cancel each other out, and we're going to be left with just an x. So if we take the composite that way, we get just an x back. So we found the right inverse. Let's try the composite the other way. So let's put f inverse of f of x. If we do this, we should also get x back. So we know our inverse function was x over 4. With the x, we're going to replace it with f of x, and f of x was 4x. So it's going to be 4x over 4. And in here, these 4's will cancel each other out, and we'll be left with just an x. So we've informally found an inverse function. So I want to give you a formal definition of inverse functions. So we're going to say let f and g be two functions such that f of g of x is equal to x for every x in the domain of g, and g of f of x is equal to x for every x in the domain of f. Under these conditions, the function g is the inverse function of the function f. The function g is denoted by f with this little exponent that looks like a -1, which we read as f inverse So, then the following will be true. F of f inverse of x equals x and f inverse of f of x will equal x. And the domain of f must be equal to the range of f inverse. And the range of f must be equal to the domain of f inverse. So let's look at another example where we're going to verify or test if two functions are inverses to another. Alright, so let's look at example 2. We're going to be given the function f of x is equal to 5 over x minus 2, and we want to know is g of x, which is equal to x minus 2 over 5, or is h of x, which is equal to 5 over x plus 2. Which one of them is the inverse to f of x? So what we can do is we can take and find the composition of f of g of x, and if we get x back, then g of x is its inverse. So let's take f of x, and wherever we have an x, we'll replace with an x minus 2 over 5. So we're going to have 5 over x minus 2 over 5 minus 2. If we clean this up, we don't like having 5 here in the denominator. So what we're going to do is we're going to multiply each term we have by 5 in both the numerator and the denominator. So in our denominator, this 5 and this 5 will cancel each other out. And what we'll have is our next line of work. It's going to be 5 times 5 is 25 over, in the parentheses we'll be left with just an x minus 2. And then 2 times 5 is 10, so we'll have a minus 10, which can clean up a little more, and we'll have 25 over x minus 12. Which, if we were trying to get this to be an inverse function, we want it to equal x, and in this case, it does not equal x. So g of x is not an inverse. Let's try h of x. So wherever we're going to do f of h of x. Wherever we have x in f of x, we're going to replace it with h of x. So we're going to have 5 over, we're going to replace our x in x minus 2 with 5 over x minus 2, not minus 2, plus 2. And then we're going to subtract 2 from that. Now what's going to happen in our denominator, these parentheses are really not necessary. The 2 minus 2 is going to cancel out and make 0. So we're going to have 5 over x. And we don't like having fractions within fractions. So to clean things up, we're going to multiply everything by an x. Multiply by x, because then in our denominator, these x's will cancel each other out. And we're going to have 5x over 5. And then our 5's will actually cancel each other out. And we'll be left with just x, which is what we wanted. So now that we've possibly confirmed that h of x is an inverse, we did the composition of f of h of x. Let's also try h of f of x just to verify we're all good. So now let's find h of f of x. And if we get x back, then hey, guess what? H is definitely our inverse. So what we're going to do is wherever we have x in h of x, we're going to replace it with f of x. So we're going to have 5 over x minus 2 minus 2. Since we don't like dividing by fractions, we can, instead of having this as 5 over x minus 2, we can rewrite this as 5 over 1 times, if you remember the rules for dividing fractions, we leave the first, and 5 is the same as 5 over 1. Change it from division to multiplication, and then flip the second fraction. So we're going to go x minus 2 over 5. And here, the 5's will cancel each other out, and we're going to be left with x minus 2. Now, I did notice I wrote something wrong. I forgot to put a plus in h of x. So this should be a plus 2 at the end, which we do need to bring all the way through. And if we do that, x minus 2 plus 2, these 2's are going to just zero out, and we're going to be left with just an x, which is what our goal was to do. So what we can say is h of x is the inverse of f of x. Alright, let's look at example 3. And in example 3, what we're going to do is we're going to look at the graph of f of x equals 2x minus 3 and g of x, which is 1/2 of x plus 3, and determine if they're inverses. So I'm going to take a minute and pull those graphs up. So here's my graph of f of x and g of x. I'm actually going to go over both of them with one other color, or at least f of x with one other color, so we can distinguish which one is which. So here in blue is f of x. You know what? I'm just going to go over g of x too. G of x is going to be here in red. Okay, so one thing we can do to verify if these two things are functions is let's look at some of their points. So here in blue, we know we've got some points that are important. We've got our y-intercept at the point 0, 3. I've also got a point at 1, -1. And I'm just going to do 2 more points. I've got one at 2, 1. And I've got one at 3, 3. So these are points from f of x. If f of x and g of x are inverses of each other, all that we're looking for, really, is if f of x has a point AB, then g of x has a point that's BA. We just switch the x and the y. So let's look. If this is an inverse, then the point 0, 3 on f of x should correlate to, and I actually wrote that wrong, that's not 0, 3, it's really the point 0, -3. That should map to the point on g of x where x is -3 and y is 0, and we have that point right here. And in blue, that's our 0, -3. Now 1, -1, which is right here in blue, if g of x is indeed its inverse, we should map to the point -1, 1, which, guess what, we've got right here. And we can actually confirm, or continue to confirm this with our other points. We've got our 2, 1, and we've got our 3, 3. If we map 2, 1 with f of x, then in g of x we should have 1, 2. Which, guess what? 1, 2, right there. And then our 3, 3, if we switch x and y, should be 3, 3. And guess what? We have a little overlap at 3, 3. So we have just verified that these two functions are inverses graphically. So there is a test you can also use to test if a function has an inverse, and it's the horizontal line test. So we learned about the vertical line test to test if an equation or a graph is a function. We can use the horizontal line test to see if the graph has an inverse. So here's the little definition we're going to use for horizontal line test. We're going to say a function f has an inverse if and only if no horizontal line intersects the graph of f at more than 1 point. In our next video, we're going to talk about one-to-one functions and finish up our examples. So stay tuned.